Hi, we are Kaori, Omar, and Ale,
and we're going to talk about the Fibonacci series.
What is Fibonacci series? Fibonacci series are a series of whole numbers in which a number is the sum of the two previous numbers beginning with 0 and 1. To get these numbers, an example will be if you want to know the fourth term. So, you put the formula, and it's 4 minus 1 plus 4 minus 2, and it's 3 plus 2. And you need to know the terms in 3 and 2, and it's 2 plus 1 is 3. That is the result of the fourth term.
Well, this beautiful man, this gorgeous man, was named Leonardo Pisano Vigolo. He was an Italian mathematician that lived from year 1170 to 1250. Well, he said to be the one that discovered the Fibonacci sequence because he was nicknamed Fibonacci. But some people say that this sequence was discovered long before him by some Eastern civilizations. So Fibonacci stated the problem of the rabbits in his book Liber Abaci in the year 1202. So the problem says this: a man put a pair of rabbits in a place surrounded on all sides by a wall. How many pairs of rabbits can be produced from that pair in 1 year if it is supposed that every month each pair begets a new pair which from the second month on becomes productive? Well, this problem it has some conditions, like that the rabbits will never die and that they will continue breeding for years and years and in an infinite number. So the explanation is that we have in the first month, the first couple is born. At the end of the second month, this couple will have already made. At the end of third month, couple 1 will have had couple 2. At the end of month 4, couple 1 will have couple 3 and couple 2 will reproduce. At the end of month 5, couple 1 will have couple 4, couple 2 will have couple 5, and couple 3 will start reproducing, and so on. So now each month we will have that the couples will have more babies and more babies, and they will never die. So this problem can be all explained easily with the Fibonacci sequence. So how can this problem be explained with the Fibonacci sequence? Well, it's simple. In month 1, you have only one couple. In month 2, you will still have one couple. In month 3, you will have 2 couples. In month 4, you will have 3 couples. So all you're doing is adding numbers up. So it's 1 plus 1 is 2. Then 2 plus 3 equals, we have 5 couples, so it's 5. So in month 6, we would have 3 plus 5 is 8 couples, and so on.
Today we're going to find out which are the first 2 numbers in the Fibonacci series. First of all, you need to know that the first number is 1. Then 1 repeats itself. Then is 2, 3, 5, 8, 13, 21, and so on. But I will tell you how do we get these numbers. You need to add up the first 2 numbers previous to the one you want to know. like this. You have 3 and you get 3 because you add 2 plus 1. You get 5 because you add up 3 and 2, and so on. So these are the first 20 numbers in the Fibonacci series. As you can see, I did the same thing over again. I add up the first 2 previous numbers to obtain the one I want. And here are the 20 numbers. So the golden ratio is the number that we obtain if we divide the 2 numbers that are successive. Like in the Fibonacci series, we have 2, right? 2 and 3. If we divide 3 by 2, we obtain 1.5. And the golden ratio is 1.6180 when it goes on and on. But if we get something similar to it, it's more than 5. And it's the same over again. Like if we divide the next number in the Fibonacci series is 3 and 5. If we divide it, we get 5 by 3 is equal to 1.6. And that's the golden ratio.
The Fibonacci series can be found in many things in nature, but here are some examples. Here is an example of a pine cone, and it's an spiral. As you can see, it's 1, 2, 3, 4, 5, 6, 7, and 8 series. Another example is a flower. As you can see, the petals are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So it's a series of the Fibonacci number.
Another example of the Fibonacci series is our own hands. We have 2 hands which have 5 fingers each, and they are separated in 3 parts. My conclusion of this project is that the Fibonacci series is present in the things we use every day, like our body and
I think he was a very clever man, because in the time he did this, mathematics and science were not like very much developed. So even though they were not developed, he had the intelligence to do this sequence and to discover all of these problems. And he did a huge contribution to humanity.
I think that he made a great contribution to nature, because now we can see anything like really specific in symmetry and in